Section 8.5. More vocabulary. Be ready to write some of this stuff down. Again, take a look at the notes that you already have. Just make sure you kind of have room for this in there. A trapezoid. A quadrilateral with exactly one pair of parallel sides. I put a star there because that's the definition of trapezoid, but that's also a property of a trapezoid, that it has one pair of parallel sides. Those parallel sides are called the bases, more vocabulary, and the other sides are called the legs. The parallel sides are bases, the other sides are legs. Again, pause it if needed to have time to write this down. There are two pair of base angles on every trapezoid. Two pair of base angles on every trapezoid. If you need a little peek at it, here's a trapezoid. Pair of base angles, two pair. Two pair is four, unless you have two pair of pants. That's only two pair of pants. But if you have two pair of shoes, you have four. Two pair of underwear, you only have two. I don't know. But two pair of base angles, there are four base angles. Here's one pair down in this corner, here and here. Those are base angles because it's touching the base. And then the other pair would be up here, touching the base. Parallel sides are bases. The other sides are the legs. Base, base, leg, leg. A pair of base angles, a pair of base angles. These are not a pair of base angles. Those are not have a name. It's a pair on the bottom or a pair on the top. Oops. Next, a midsegment. What's a midsegment? It is the segment that connects the midpoints of the legs. Segment that connects the midpoint of the legs. So if I go back up and look at this trapezoid that I just kind of sketched out, we would put midpoints on the legs, and then we would cut through it and make a midsegment. We had midsegments for triangles, not really any different. Midsegment is always parallel to the bases. Bases, no matter what. This midsegment will be parallel to that base and that base. The bases are already parallel. The midsegment is also parallel. And how big is a midsegment? It's half the sum of the two bases. So basically it's the average of the two bases. Take the top plus the bottom, or small base plus big base, add them up, cut it in half, and you have a midsegment. Half of the sum, if you'd rather write it as the average of the two bases, it just basically means add them up, cut them in half. Enough vocabulary, almost. Once we get done with isosceles, check the spelling on isosceles. The properties of an isosceles trapezoid is a trapezoid with congruent legs. Not all trapezoids have congruent legs. Only the legs, not the bases. The bases can't be congruent. It will have congruent base angles, and it also will have congruent diagonals. So if you're looking at an isosceles trapezoid, leg congruent to leg. Congruent, congruent. Parallel, parallel. Base angles are congruent, and we talked about this already. A pair of base angles. These two are congruent to each other. These two are congruent to each other. But the top and those two are not. Consecutive ones are not there. Congruent diagonals. If I sent a diagonal right through there, it'd be the exact same size as a diagonal right through there. And some of you might be saying, well, isn't that true of all trapezoids, not just isosceles? No, be careful. I mean, when you think of trapezoids, a lot of you picture that, but this is way different. That's a trapezoid, but all those properties are not true of a trapezoid that is not isosceles. All right, enough vocabulary. Now, let's do some example problems. Again, hang in there with the math. I know adding 5 and 13 is a lot, but I think you can do it. And if you can't, I'm going to let you use your calculator. But if you know that 13 and 5 are the length of the bases, these are parallel, which makes it a trapezoid. Those are congruent, which makes this a midpoint. which means we have a midsegment. You put all the pieces together that we just learned, and we can find the length of the midsegment by saying that it's the average of the other two legs. 5 plus 13 is 18. You cut it in half and get 9. But notice this too. 5 plus 4 is 9. 9 plus 4 is 13. Makes sense. That's how averages work. A non-isosceles trapezoid, that's okay. It doesn't have to be isosceles. That's still a midsegment. This time, they gave us the base down here. They gave us the midpoint, not mid-segment. They didn't give us the top. So we could set up a pretty, not so complicated, but not so bad mathematical equation, a little algebra. The average of the two bases, add them up, cut them in half, should equal 12. You could solve that with cross multiplication and then subtract. Or, like the little stepping stones that I used here, you could look back at this and say, oh, but I could go 16 minus 4 is 12, 12 minus 4 is 8, and that works also. Here's the trapezoid. We know it's a trapezoid because it has a pair of parallel bases. 102 degrees over there. If you have no idea what to do, you go back up in here. Look at this. Quadrilateral with exactly one pair of parallel bases. Parallel sides are bases. Other sides are legs. Two pair of base angles, but it doesn't say anything about their sizes. None of them. And it's not an isosceles trapezoid. So you got to go back and look at this and be like, well, how am I supposed to do this if it's not a property of a trapezoid? Right here. Parallel lines. Just because your picture doesn't look like this, the way we learned them way back in semester 1, you remember that? That was a really long time ago. But you so easily identified, oh yeah, those are corresponding, alternate interior, alternate exterior angles, and we have consecutive interior angles. You did that. You caught on so fast to that, and it was so easy. But unless you have two parallel lines and a transversal that goes right through them, you don't always recognize it. But these are technically two parallel lines and a transversal that goes through it. What do you know the properties of parallel lines? These are consecutive interior angles. Consecutive interior angles are the two that are supplementary to each other. If that's 102, that's 78. Or you could say, I know my alternate interior angles, and that's a linear pair. Doesn't matter how you get to it, but that is definitely consecutive interior angles. And consecutive interior angles are supplementary. And then go ahead and do the same thing over here. 180 degrees, 180 minus 36 is 144. Notice I put the degrees on it. And if you added all four of them up, it is a quadrilateral, so it better add up to 360 degrees. Isosceles trapezoid. These are a little bit easier because you, of course, have the parallel lines, but a reminder on isosceles trapezoids, they have congruent base angles. If they have congruent base angles, and if this is 75 degrees, then this is also 75 degrees. Doesn't tell you how many these are, but we go again with parallel lines and a transversal. Consecutive interior angles, 105 degrees, 105 degrees. Add them all up, they equal 360. We're cruising, and if we're cruising too fast, you pause it. More vocab, finishing up quadrilaterals. This is our last one, a kite. Kite is another quadrilateral. This is kind of weird, with two pair of consecutive congruent sides. A quadrilateral with two pair of consecutive congruent sides. Write that down. We'll get back to it later. Pause it if you need to. But opposite sides are not congruent. And I'll show you why that has to be a but in there. Why does my kite have a but? I'll show you why, and then when I draw a diagram. Also about kites, their diagonals are perpendicular. Diagonals are perpendicular, and exactly one pair of opposite angles are congruent, meaning there's always one pair, there's never two pair, and there's never no pairs. Okay? Let's describe this. Quadrilateral with two pair of consecutive congruent sides. So we're going to draw a quadrilateral. I mean, you all know what a kite looks like. There's a reason why it's called a kite. Okay, and that kite, here's my two pair of consecutive, meaning next to, consecutive congruent sides. And then it has another pair of consecutive congruent sides. But, here's my kite's but opposite sides are not congruent. You can't have opposite sides congruent because watch what would happen if you did that. I'm going to clone this, see if it lets me. If I did this, and then this consecutive pair was also congruent, oh no, now we have a rhombus. A rhombus can't be a kite, and a kite be a rhombus just because of one. So they put in the rule of you can have one, a pair of consecutive congruent sides and another pair of consecutive congruent sides, but opposite sides cannot be congruent. That's how it's describing it. Next up, the diagonals are perpendicular. That's probably the best way to ever draw a kite. I did a pretty good job, but if you really want to draw a kite, draw two perpendicular, draw a cross, and then just connect the edges of the cross. They're perpendicular, so this is always going to be a right angle in there. It'll always have exactly one pair of opposite angles that are congruent. Exactly one pair of opposite angles that are congruent. You got to look at this kite and try to figure out where is that one pair. Okay? That one pair is always going to be, if it's upright the way we would consider a kite, across from each other side to side. And if you're not sure and this looks like, I don't know, those look like they might be congruent, then draw your kite like this. And say, oh yeah, they're definitely not. This is almost a 90-degree angle. It's like 88 degrees. This is only about a 30-degree angle. If you exaggerate the tail of your kite, or the bottom part of it, you can easily see that it gets smaller and smaller and smaller. Or you could say, this is the top of my kite. That's obtuse, that's acute, it's not even close. But look at the sides. The two angles here and here are definitely congruent. Do you have to memorize those properties? You got to memorize the properties because otherwise how would you know how to do this work? Find the side lengths. How can I find the side lengths if all I know are the diagonals? Let me go back up and look at the diagonals and the side lengths. Doesn't say anything about that. So I have to use prior knowledge, if you can believe that in a math class. There is that rule. Diagonals are perpendicular. How does that help? It helps us with a squared plus b squared equals c squared, and c is 10. Okay, then we do it over here with a squared plus b squared equals c squared, and you get that. I bet we can reduce or simplify 160. Let's check and see if it's a perfect square. Yeah. Or make it 180 like you should. I'm going to break 180 down into 10 and 18 because I can. Break that down into 9 and 2. Break this down into 2 and 5. And 3 and 3. I got a pair of 3s, a pair of 2s. So this side is 6 square root of 5. If you forgot how to do that, slow it down and go back and look at it. Next, we need the other sides. Or do we need the other sides? I don't know if we do need the other sides because it said on right here, a quadrilateral with two pair of consecutive congruent sides. So this must also be 6 square root of 5, and this must also be 10. And then we can say, oh, here's something else I discovered. If that's 10 and that's 8, then this must be 6 to make it a 6, 8, 10 triple. But we didn't say anything about diagonals being bisected. That's because they're not. This diagonal is not bisected. It's 12 over there and 8 over here. But this diagonal will always be bisected. but only one of them is. Last one. Find the measure of angle J and the measure of angle K. We got to get a little creative here. They gave us the two sides that are not congruent to each other, or the two angles that are not congruent to each other. But we do know that exactly one pair of opposite angles are congruent to each other. So if one pair of opposite angles are for sure congruent to each other, we can call them both the same variable. Instead of J and K, we would call them both X. What we do know about a kite is that it's a quadrilateral. How many degrees in a quadrilateral? 360. How many degrees do we already have taken care of or accounted for in our quadrilateral? About 200. Therefore, we have 160 degrees left. What am I going to do with that 160 degrees? And if I have two angles, I could do algebra, or I could do simple calculation of if two angles add up to 160, they each equal 80. Double check your math. 132 plus 80 plus 68 plus 80 equals 360. And opposite angles are congruent. That's it. Kites, trapezoids, and isosceles trapezoids. All done with chapter 8.